We're still with the testing hypothesis, and if you notice, what we have done so far is that we've dealt with only the situation where we have one sample, and we were interested in the numerical variable. So the statistic that we looked at was in X bar, and the null hypothesis had to do with the mu equal. Um, the same approach applies if you were interested in a categorical variable, and your statistic is going to be proportion p, and the population parameter is going to be pi. Okay, so that's what we're going to do in this video. Is everything we covered with the population mean applies, but here your z is going to be p minus pi over the square root of pi into 1 minus pi divided by n. And you remember that pi is the proportion in the population, and it's going to be provided to you by the null hypothesis. P is the proportion in the sample, and N is sample size. And remember, the condition for the sampling distribution of the proportion to be normal, that N into pi into 1 minus pi has to be greater than or equal to 5. When we were dealing with the confidence interval, that condition had to be amended because we did not have pi. So we had to say n into p into 1 minus p. But here in testing hypothesis, you are provided with the pi. And therefore, you're going to revert back to the original condition, which is n into pi into 1 minus pi. All right, so let's see if we can actually do the example. Here we go. A new drug claims that those who take it after having myocardial infarction will have a survival rate of 80%. Okay, so this is the claim. The studied sample, was 49 patients on MI, took that medication, and 33 survived. So the observed proportion in the sample was 67%. What can we say about the claim? So the claim was 80%. We observed in the sample 67%. I hope by now you realize that just because your sample statistic is 67%, it doesn't mean that the parameter is 67%. By now you understand that even if the parameter is 80%, you may get a sample with the statistics of 67%. But the question is, how likely is that to occur? And therefore, this is the whole idea of testing hypothesis. All right? So we're going to follow the 7 step that we have covered before. You start with a null hypothesis and an alternative hypothesis. And again, if you look at your null hypothesis right here, it follows the same rationale. Something equals something, and you're using parameter values. So you're going to say pi is equal to 0.8. Now, for this to be complete, you have to tell me proportion of what in what population. So you'd have to say proportion of patients suffering from MI surviving while taking the drug is 80%. Okay, you just cannot say proportion of MI patient, that would be wrong. And you cannot say proportion surviving, that would be wrong as well. You have to specify that this is the proportion surviving with patient after MI taking the drug. So why did we choose 80%? Because that was the claim made by the drug company. And therefore, we take things at face value. This is the presumption of innocence. We say, okay, the drug company is innocent from making any false statement, so we're going to believe them, and we're going to see if this is true or not. The alternative hypothesis, again, is going to cover everything but equal to 80%. So we're ready to have an alternative hypothesis if the null hypothesis turn out to be not true. Step number 2, you know by now that step number 2, you're going to assume that the null is true, and we're going to set alpha. Since nothing was said about alpha, you're going to calculate alpha, or you're going to set alpha at 5%. Step number 3, since this is a proportion, you're going to use the z. There is no t with proportion, okay? But before we do that, before you do the step number 3, we're supposed to check if actually we meet the requirement for n into pi into 1 minus pi. So let's see, let me go back a little bit. The pi was 0.8. The number of the sample size was 49, and then 1 minus pi is 0.2. So let's see if I can calculate that quickly. So you're going to take 49 and you're going to multiply it by 0.8, and then you're going to multiply it by 0.2, and that gives you 7.84, which is greater than 5, and therefore the sampling distribution of the proportion has a normal distribution, and therefore we can use the Z. Notice I used the 49 into 0.8 and not into 0.67 because I am provided with the pi. Now, why am I provided with a pi? The null hypothesis provided me with a pi. So therefore, I can use the Z, and the Z says the observed proportion, which is 0.67, minus the population proportion, 0.8, divided by the standard error of proportion, which is pi, 0.8, into 1 minus pi, 0.2, divided by the sample size, 49, and then you square root the whole thing. That gives you a Z of negative 2.21. Okay, now when the Z is negative, to get to the p-value, by now you know that as extreme as means that you're going to take the negative value and go down. So Z is less than negative 2.21. Don't forget to multiply by 2 because you need the both sides. And you end up with a p-value that is 0.0272. Step number 5, you're going to compare that p-value to alpha. And obviously that p-value is less than alpha. So that takes you to step number 6. You're going to reject the null hypothesis, and you're going to reach a research conclusion, meaning that there's evidence that the claimed survival rate of 80% is not true. And based on the sample, the survival rate is much lower. Again, why it's much lower? Because we believe it to be much lower based on the sample. Okay, now just to tie up things, remember we had covered previously the confidence interval. It turns out that you can sorry, let me go back to, here we go. All right. So it turns out that there is the relationship between testing hypothesis and confidence interval, and meaning that you can reach same conclusion whether you do a testing hypothesis or you do a confidence interval, as long as there is the relationship is that if you're testing with an alpha of 5%, then your confidence interval has to be 95%. If you're testing an alpha of 1%, then you have to do a 99% confidence interval. Both will yield the same conclusion. Okay? So if you're going to reject the null hypothesis, the confidence interval should not include the suggested mu. Remember, rejecting the null hypothesis means that the mu suggested by the null hypothesis is not acceptable. And if that mu is not acceptable, then it should not be inside your confidence interval. And the opposite is true. If you fail to reject the null hypothesis, it means that the suggested mu is not rejected, it's accepted. And therefore, this mu has to be included in your confidence interval. Okay, and that could be generalized, as I said, if you change alpha to 1%, you do a 99% confidence interval, and so on and so forth. So let's see, I don't have example here, but I will make another video where I will tie up the confidence interval with the testing hypothesis. I hope you find this to be helpful.